This video explains how to submit a Monte Carlo Lennard-Jones simulation to the BYU Supercomputer using the C code that Dr. Knotts wrote. I'm assuming you've logged into the BYU Supercomputer and you should be in your home drive or your home directory when you first log in. So I can ls, list directory, ls, and you see I have a lot of folders. You likely won't have this many, but you should have one called groups and you should have one called no backup. I'm going to start in no backup. So I changed the directory into no backup, cd, no backup. And when I list that directory, you'll see I have two other folders, where you want to go is auto delete. That is where you should always run your simulations. That's the fastest storage they have on the supercomputer. When I list that, you'll see I have a few folders here. I've been doing some testing with Hello. I'm doing some work with Dr. Bundy, with Onkinase. I'm going to simply make a directory here to hold my Lennard-Jones results. So mkdir, and I'm just going to call it Lennard-Jones, LJ. I now need to copy several files into this folder. It'll be a little easier if I go to where the source files are. So I'm going to cd into my home directory. When I type cd and hit enter, it takes me to my home directory and I can list that. You can see that I'm back where I started. I can now go to groups. So cd groups, you have one called grp_CHEN 513 with your year that you're taking the class. You want to go into that group and everyone in the class has access to the stuff in this group. If you write stuff or if you delete stuff, it's going to be affecting the whole group. So just only copy stuff from here. When I list that directory, you'll see there's something called ljmdmc. This is my C code that I wrote to do Lennard-Jones simulations. There's also something called submit_ljmdmc.sh. That is a submit script we'll also need. I'm going to first copy that submit script over to the folder where I want to work in no backup auto delete. Here's how I do that. cp is the copy command. I first need to tell it what I want to copy, which is submit. Notice I tab over to autocomplete. And then I need to tell it where I want it to copy to. You need to go all the way back to your home directory. And the way you do that is do a tilde. That says start my home directory, put a / in, and then remember that there's something called no backup, auto delete, and we created a folder called LJ. So I'm going to copy that there. I now want to go into the folder ljmdmc. So I cd into ljmdmc. When I do that and list that directory, you'll see it has a bunch of .c and .o files. That means I've compiled the program. .c is the code, .o is the compiled version. And it made the executable called ljmdmc gcc 14-1. That's a name I gave it. There's nothing special about that. I just gave it this nomenclature so I can remember what version of compiler I used to compile this program. I want to copy that file in red. So I do copy cp. I tell it I want to do ljmdmc gcc 14-1. And again, I want to put that in the folder I created to run my simulations. Those are all the way back in home directory, tilde, and then I type no backup, auto delete, LJ. And now I've copied that executable over to where I want it to run. I also need some input files. So I'm going to go to cd into sample files. Notice there is a folder here called sample files. When I go into that and you list that directory, you'll see there's some sample files for both Monte Carlo and molecular dynamics simulations. I'm going to go into the Monte Carlo one. And when I list that directory, you'll see I have a .input file and a .output file and a .core file. The only one I need really is the .input file. You'll notice that I've named these files with the number of particles, 500, the temperature, dimensionless temperature, 0.085, and the dimensionless density, 0.9. So I'm going to copy cp again. And again, I need to put that in the folder where I made in no backup auto delete LJ. I go to my home directory because that's where it's referenced, no backup auto delete LJ. And now I think I have everything we need to run this job. So I'm going to go to no backup auto delete LJ. I can cd, use tilde, no backup, auto delete LJ. And now when I list that directory, I have the things I copied over so I can submit this job. You have the executable in red, you have the input file, and you have the submit file. I'm going to first look at the input file. I use VI editor. There's some others you can use on the supercomputer. You'll notice that this file, this simulation, is set up to run a Monte Carlo simulation for 500 particles at a dimensionless temperature of 0.85 and a dimensionless density of 0.9. I also set that we want to do 10,000 equilibration steps, which are Monte Carlo sweeps in this case, 20,000 production steps. I'm cutting the Lennard-Jones potential off at 3 sigma, or dimensionless length of 3.0. The max delta is dimensionless at 0.1. This is important coordinate. I'm going to generate the coordinates onto a lattice. If you have a pre-equilibrated file, you can place that here. I'm going to output the instantaneous properties every 50 steps. I have a random number seed of -234, and I'm going to do an RDF between 0.8 and 4 dimensionless length with 100 bins, and I'm going to accumulate that every 25 steps. The submit script starts with submit, so I VI submit. You're not going to have to change most of the things in this file, but I do want to show you a few things. This tells me the time you want to reserve on the supercomputer. 3 hours should be enough for this job. I need 1 processor. I gave the name of the job capital L, capital J. You can name that whatever you want. There's 3 things you need to change right here. Working directory is going to be whatever directory you called it when you first made it in no backup auto delete. We made something called LJ, but if you were doing other jobs, you could make a different folder and save the work in that folder. The in file, I file, is whatever my input is called. The O file is not present in your current directory because the program's going to generate that. You could call this anything you want. You don't have to change anything here, and you don't have to change anything here. I just want to explain what's happening. We're first going to change into your working directory where we just copied everything. And then we're going to run the program ljmdmc. Remember, this is the name of the executable that we copied over. And I give it the name of the input file and the name of the output file. Again, these purple things are variables so that all you have to change is up here and you don't have to remember this syntax. I'm going to quit out of that. How you submit any job on the supercomputer other than Gaussian jobs is you type sbatch and then you give it the name of the submit script. Submit ljmdmc.sh. When I hit enter, you'll notice it's been submitted, and I can check my jobs by using SQ. So SQUEUE-U, your username. If I list my directory, you'll notice it created a slurm out. That's the scheduler called slurm. And it also created the output file. I'll just show you that you can look at the output file. And you can see that it's already done 100 iterations.